Okay, the golden ratio. Who drew this picture? Do you guys recognize it? Leonardo da Vinci. Yes, he was a genius. And he was a Renaissance man, and then he could do lots of different things. And he was an artist. He was a designer of inventions. And one of the things he noticed was this kind of cool ratio. And it's been replicated by a lot of other people too, but this ratio called the golden ratio. And he included it in some of his paintings. And he knew that it was this amazing number that appeared in nature all the time. All right, take your arm and kind of hold it out in front of you, like lay it down on your desk or something. From your elbow to your tip of your fingers, if that's the first distance, okay, from here to here, okay. And by the way, that's also known as a cubit, in case you haven't heard of that one before. If you compare that to the distance from your elbow to your wrist, if you take and you divide those two, it comes out to be the golden ratio, which is about 1.618. Now, what is so special about this? That's a weird decimal. I mean, 1.618, that's to the thousandths place. But it's amazing that that ratio appears on your body in so many ways. It just blows your mind. I'll give you a few examples. If you put a frame around your face, the width of your face compared to the height of your face, what do you think you get when you divide them? 1.618. Exactly. If people have different shaped faces, but they're going to revert to an average of about the golden ratio. And if you saw somebody with a really wide face, wouldn't it like catch your attention? Because it doesn't what? It doesn't fit with kind of the norm. Okay? So another thing that when you divide it is going to come out to about 1.618. Am I saying it'll be exactly perfect? No. I'm saying that about this ratio is, see the green line on the board here? The height of the dude compared to the height up to his belly button. Take and divide those two on a normal shaped person, and it'll be 1.618. Next one. I already talked about that one. The height from your shoulders to the top of your head compared to your chin to your top of your head. Golden ratio. Next one. From your top of your head down to your shoulder compared to the top of your head down to your belly button. Golden ratio. It's from here to here compared to here to here. I already did that one. There's one on your fingers. It's all over the place. It's amazing. So enough about that. You've seen that on the human body. Well, it's also, ever heard of the Fibonacci series? You know how that one appears in nature a lot? I'm sure you heard that one when you were a kid. The Fibonacci one is 1, 1, what comes next? 2, and then 1 plus 2 makes 3, and then 2 plus 3 makes 5. Okay, 1, 1, 2, 3, 5, and it just keeps going on from there. When you get to the 13th one, what do you think starts happening when you divide both of them? Divide the number by the number before it. What do you think you get? 1.618, exactly. All the Fibonacci numbers from there on out, when you divide them, they all come out to 1.618. Isn't that weird? And the Fibonacci number, at least I hope you've seen that one demonstrated in nature. It's in seashells. It's in spirals on pine cones. It's in sunflowers and the seeds going around in the sunflower. It's just amazing. That number compares everywhere. And then the golden ratio is part of that number. Next one. See this? 1 plus 1 over 1 plus 1 over 1 plus, and you just keep doing that over and over and over again. What do you think you get? Only ones and pluses and some divides. But yet, it comes out to 1.618 exactly. I'm going to prove that one to you because it's kind of fun. Grab your graphing calculator, and I can show you how to put that one in. It's kind of cool. I'm going to pause while you get those ready. Okay, do this exactly. Clear off your screen completely. Get to the home screen and have it clear. Then hit 1, hit enter. That way you've got 1 in its memory as answer. Okay? Now we're going to go 1 plus 1 divided by, And instead of saying 1 here, we're going to say answer. All right, so I'm going to go second answer. Now, some of you that have the new operating system is going to say SVAR or something like that. Now, hit enter. Now, the first time you hit enter, it's like, wait a minute, it's 2. And that makes sense. 1 plus 1 divided by 1. It would be 2. But then if you say enter again, what it's going to do is take that and put in, instead of putting in 1, it's going to put in the number in front of it. And it's going to get closer and closer to that ratio I showed you on the screen. And hit enter a whole bunch of times and see what happens. As it goes farther and farther. 1.618, 1.618, 1.618. Isn't that awesome? I have never sat here and pressed the button 1,000 times. And that's just because it may even be going farther, but when it rounds it to the number of places on the screen. You know what I'm saying? All right, so, and the golden ratio does go farther. In fact, that probably is the golden ratio. It's just farther than I said it. You know, 3.14 is pi. But really, what is pi? 3.14159265355, blah, 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 blah. Well, the golden ratio probably goes on farther than 1.618. I've never really looked into that. I bet it turns out to this. Just keep hitting enter a bunch of times. It'll probably tell us what it comes out to be. All right. So the point is you've learned something cool about the golden ratio. I'm going to get this out of the way now and say, see that box around the Mona Lisa's face? What do you think the ratio is? Ever seen that famous picture, The Last Supper? It's made up of squares and rectangles. The big rectangles, take a guess what the ratio is. There's a shocker. All right, and this one, that great big building, I think that's the Parthenon. I'm not positive. I think it is. It's made up of squares, golden ratio, rectangles. All right. Now let's talk about some of these old words that you may or may not remember. A line. It's so thin in a line you really shouldn't be able to see. Because if you actually draw a line, you're making it have a width, and lines are defined as having no width. And how about their length? So it should be what if it goes forever? The length should be what? Infinity. All right. And we represent that by having little arrows on the end of it. The transversal. Ever heard of like transcontinental? Know what that means? Across the continent. What do you think a transversal goes? Across the other line. So this is the transversal right here. And it's going across the other two lines. The other two lines are parallel in this case, which means that we have a lot of relationship here that you should know. It makes a bunch of angles like that angle A there. That's a big one. So what kind of an angle is it? Obtuse. How about the small kind? Acute. How about the kind that goes straight across? 180 degrees, they're called what kind of angle? A straight angle. How about if they go more than 180, like 190 degrees? It's called a reflex angle. All right, good. Next, let's talk about corresponding. A is an angle, and it corresponds to what other angle up here? A corresponds to E as in elephant. I know A and D are equal, but that's not what I asked. Corresponding angles are like A and E. You can get that? They're both the upper left-hand corner of the set of angles that they're in. So, like, what corresponds to B as in boy? F. All right. And yes, corresponding angles are equal, but so are the angles across from them. Do you know what they're called? No, the angles that are equal aren't supplementary. That's different. Those are ones that are across from each other, like A and D or C and B, are called vertical angles. All right, got to get these terms back in your head because these are the kind of things that are on the MCA. You got to know all these things. All right, next one, interior angles like CD, E, and F. Those are all interior. Does it make sense to you? They're on the inside. So what do you think A, B, and GH are called? Exterior angles. Only makes sense. And then there's alternate interiors. So if C, D, E, and F are all the interiors, then what is alternate interior to C? F. And those will be the same. So if C is A is like 60 degrees, then what's F? 60. And alternate exterior would be like that one and that one. Does that make sense to you? They're on alternate sides of the line. All right, we'll stop this for now.